Today we're diving deep into value versus reference types. This is probably the most important concept for understanding how C# really works. We'll explore where these types live in memory, the stack, and the heap, and why that matters for performance. And we'll see how this distinction affects everything from simple assignments to passing data to methods. Let's dig in. Here's the thing that took me forever to understand. This isn't just academic computer science stuff. The difference between value and reference types affects how your code behaves every single day. Bugs that seem impossible to track down? Often, it's because you didn't realize you had two variables pointing to the same object. The stack is super fast and organized. Think of it like a stack of plates. You can only add or remove from the top. Local variables and method parameters usually live here. When a method ends, its stack space is immediately reclaimed. The stack is small, typically just a few megabytes. That's why you get stack overflow with infinite recursion. The heap is much larger and more flexible. Objects can be any size and live as long as needed. All objects and arrays live on the heap. This is where your class instances go. The garbage collector manages the heap, cleaning up objects that are no longer referenced. Value types store their data directly where the variable is declared. Here, x contains the actual value 42 right on the stack. Reference types are different. The actual object lives on the heap, but the variable on the stack just holds the address of where to find it. This drives me crazy when debugging. With value types, assignment copies the data. With reference types, it copies the address. Two variables, one object. When you pass a value type to a method, it gets a copy. Changes don't affect the original. But with reference types, you're passing the address. Changes affect the original object. The ref keyword lets you pass value types by reference so the method can change the original. You need ref at both the declaration and the call side. All the primitive types are value types: integers, floating point numbers, booleans, and characters. Structs are value types. Datetime is a struct, not a class. You can create your own structs too. Enumerations are value types. They're basically named integer constants under the hood. Value tuples like int, string are value types. They're lightweight containers for multiple values. Every class you create is a reference type. This includes all your business objects and models. Arrays are always reference types, even arrays of value types like int. The array itself is on the heap. Strings are reference types, but they're immutable. You can't change them after creation. Special behavior. Delegates, interfaces, and anything that can be null except nullable value types are reference types. Strings are weird. They're reference types but immutable, so they act like value types. When you change a string, you're actually creating a new one. Boxing wraps a value type in an object on the heap. It's expensive. This is why we use generics like list instead of array list. Value types are allocated on the stack, super fast. No garbage collection needed, they just disappear when out of scope. Arrays of value types are contiguous in memory. This means better CPU cache usage and faster iteration. The classic bug, two variables pointing to the same object, you change one and somehow the other changes too. Now you know why. Making huge structs thinking they're faster. If your struct is over 16 bytes, the copying overhead often makes a class better. For the love of all that is holy, make your structs immutable. Mutable structs lead to the weirdest bugs you'll ever see. Value types store data directly and copy the actual values on assignment. Simple and predictable. Reference types store addresses and copy those addresses on assignment. Multiple variables can reference the same object. Understanding stack versus heap helps you write more efficient code and debug tricky issues. Small, simple data, value type. Complex objects that need to be shared, reference type. It's about picking the right tool. Next up, we're diving into strings. They're reference types with special behavior that trips up everyone. We'll explore string immutability, when to use string builder, and why string concatenation in loops is a performance disaster. Trust me, this stuff matters in real applications.